I hope I kind of gave you a good introduction into what the opportunities are with light, what are directions we could look at. And let's talk now about what would happen if I succeed. Let's say I fast forward 10 years ahead and I have a great radio access technology. I'm able to deliver data. It's all low energy, sustainable, working fine, exactly as I said the mission statement of the project would be. What would I do with that? Right? I can't ignore incumbent technologies. I can't ignore whatever is out there. So let's talk first about what happens if we succeed. It's still an interesting part of the introduction because it's good to dive quickly into technical details, but we need to know what happens once that stuff is done. I used to write my papers by doing this system model, simulation, blah, 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 and suffering with the introduction, thinking this is just the boring part, right? Copy, paste from other papers. The older I get, the more I understand that this is actually the most important part of your work. Why are you doing it? What's the idea behind it? Why should we pay attention to you? Why is not there a solution? Why is it new? And what will happen if you succeed? If I paid, think of it from a customer perspective, give you 50 million, what will you give me? Right? As simple as that. So let's talk about integration. And that means let's talk about use cases. What are we going to use those technologies for, and how are we going to integrate them? What is there? So I think for light, if you say, okay, what could be the use cases that would be kind of interesting in terms of technology, market, and kind of general impact. To me personally, it's Industry 4.0. I see these factory floors or even residential areas or enterprise scenarios as critical. There is a lot of interest, a lot of demand for very, very new way of networking, new architecture. So this is really, really promising. And as I said, if you had the technology today, you're doing trials tomorrow. Smart building, number 2. Indoor applications, really, really important. Most people are indoors. Most traffic comes from indoors. So this is really, really important. Enterprise broadband, you need to be careful. It's not throughput. It's latency. It's reliability. We still have, a lot of bandwidth. We have a lot of wireless networks, but I'm sure you're still experiencing frozen screens when watching videos. Not perfectly smooth yet, given all those fantastic progresses in the last year. So reliable, seamless, latency-aware, reliability-aware broadband is still very, very likely. And yes, it's essentially the mainstream market. There's the most money in this space, right? So teleconferencing, smooth VR teleconferencing, not a reality yet. Needs a lot of work. And the last hop, the wireless one, is still the critical one, right? So a lot of potential there. This is new and unexplored. A lot of work, lots of pioneering work, but we don't really know how the players like BMW, Mercedes, car industry, or IoT developers will look at that regulation. Will we deploy on lampposts or not, or what does it take, and so on. So vehicular applications are very intuitive if you think about it. A lot of cars, a lot of need for new applications, but it's unexplored. A lot of legal challenges, so it's a bit tricky environment. But let's just look at the technology maybe first, right? We need to get that work because in that way we can shape what will happen, right? Hospitals, power plants, banks, and defense are interesting applications that are happening nowadays. Nicola will probably talk about it more. But again, you need to be careful what's the kind of, universality of the technology if you want to deploy, if you want to develop kind of fundamentals. These are very concrete applications, right? Could be actually very small in size. Could give you a lifetime job, but if you want to work on a general technology, you need to kind of abstract yourself to these higher demands. If you want to jump into the kind of, verticals today, it's in this space.
So which of these applications, use cases, you think RF can be used for some fundamental reasons?
So these ones are the ones that are sensitive to RF interference, or there could be some issues with, let's say, CT scanners being sensitive to interference of anything. Nuclear plants don't like anything that's not under their control in general. Aircrafts, we all know that it doesn't really matter whether your phone is on or not in the airplane, because I don't want to fly in an airplane that is sensitive to my phone being on, right? But still, it's better not to have any interference. It's just, it's a place where people start being a bit irrational. I prefer to turn off my phone on my own because I want to end in the destination today, right? Banks, not really sure what they want, but why not, right? And defense, yes, they have a lot of great scenarios. Lasers are reality. They're talking with lasers to drones and so on. So defense is definitely a number one area. But but you wouldn't get too many details. If you work for DARPA, no one will talk to you until it's all done and published. So I don't personally have any good picture, and those who know will not tell you anyway. So, but yes, I think military is, as always, at the forefront of innovation. They definitely are interested in these areas. So, okay, I think I'm out of my time, right? Finished. End of story. I have a couple slides. If there might be more communications. Is the next type of traffic that's coming, and maybe on a massive scale, millions of nodes talking to each other. Ultra high densities, a lot of networks, nodes moving around, and each of them being supported with fantastic service. Nothing will go wrong. These are crazy numbers. I just think the market's trying to kind of see what we can deliver and how far they can push their visions, right? So it's kind of iterative game. I ask you too much, and I deliver half of it, so next time I'll ask you less, and we kind of converge. Next time I kind of do a better job. We kind of converge somewhere where the technology will push us. But essentially this means there is demand because the customers, they have a lot of great applications. This is what they would kind of imagine they need, and it's up to us to go as far as we can, right? So let's see. With communication, LightEM networks, thanks to their low protocol stack, we can actually do extremely low latency. So it's really all possible. There is market consideration. I'm going to kind of skip through that you still need to consider once you're done with the design or even when during it. You need to have a really strong case. That's why I spent so much time on the introduction. Why should I invest into you? That's the only question you'll be asked, right? What is the technology, the architecture, the network, the proposal that you're doing? It needs to be easy to deploy, easy to integrate, and it should be configurable and safe and all those things that everybody likes. But these individual items are research on their own, right? So it's not easy to get everything right. So let me quickly skip through the integration slides. I tried to kind of, maybe I should spend even more time on this slide, sort it according to the level at which the technology would be integrated. The level meaning the OSI model, open system interconnect. So we have multiple layers: physical, medium access, routing, transport, and then presentation, stuff happening in the kernel. And at every layer, you can take the new technology that you developed and plug it into the other one and start exchanging data between the two of them seamlessly, assuming that you've done a good job on the integration side. So let's go through multiple options of how you can integrate existing technologies and the new light communication ones at every single layer. Or let me give you just these. I think I have 4 slides on these 4. This is just formatting of data. It's not really important. 2 minutes. Let me do a very quick job. Integration with Wi-Fi. I can have a hybrid CPE. I can start integrating on transport layer, so TCP. I can take data flows, split them, and route them through different technologies, and reaggregate them somewhere in software. This is a great way of doing it with 4G, 5G, wireless networks, landline, anything. It's physical infrastructure independent. It's happening on transport layer, a TCP layer, let's say, or UDP layer. I can take an extra step, and I can take data that's coming from my 4G or 5G network and route it through different gateways that have been allocated through some secure channels and deliver data to the endpoint where the process is reversed. So essentially, it's a routing topology. Everything is managed somewhere, and then I suddenly bypass the data, send them over a parallel path, and deliver it to my end device that, of course, has multiple interfaces and is able to work. It can happen maybe only on data plane. That's the 5G picture. I don't have it here. And the control plane would be just controlled by a completely different interface. So you can have actually very interesting cross-technology designs. You can start integrating on medium access. Let's say you have an Ethernet modem, and you just broadcast whatever comes in over light to the air, all synchronously. Then you become, you have some kind of sub-handover architecture. But essentially what you have created is some kind of broadcast medium that takes anything that's on the wire and sends it over light to anyone anonymously. And then the addressees simply collect the data. And we would be talking about integration on the Ethernet level. Very interesting for the guys working with Ethernet in companies, something that they're quite interested in. It's a flat architecture. It's super fast, and it kind of works. Last slide. You can do everything on physical layer. You can just take light as a way of delivering data and put some kind of abstracted cloud run infrastructure on top of it that then does the job, right? Very complicated, very flexible, cutting-edge research, right? So let me finish here. Thank you for your attention. I hope, okay, I'll do you the favor and skip this one here.